Welcome to this video. My name is Steve Bartlett. I'm a technical marketing engineer supporting CX switching, and this is one of several software enhancements in the 10.07 release, and this one's impacting or affecting the debug for OSPF v2 v3 packet filtering. So what's changed? Well, now we have a new bucket or a submodule called packet. All OSPF packets now are grouped into this debug submodule called packet for OSPF v2 and OSPF v3. Nothing else has changed. All other logs in debug not corresponding to OSPF packets for v2 and v3 remain as is or unchanged. Now we get two benefits. We get better readability of OSPF debug output, and we get the ability to do more granularity in our filtering with the debug module for OSPF. So let's have a quick look at the CLI. It's very straightforward. Debug OSPF v2, v3. We've got the options of putting v2 or v3 there, and then we've got the submodules underneath this next as a next CLI output. So we've got all event config IPsec for v3 only. These are existing ones. The new submodule is called packet, and if we was to put that in the command string, say for OSPF v2, debug OSPF v2 packet, and then we get all these additional filters to filter out on VRF, OSPF instances, interfaces on a port, which you can put that in, packet, an IP address of one of our neighbors for either v4 or v6. And then we've got this option here, OSPF v2, v3 packet severity debug underneath the packet submodule. Default is, by the way, the default setting for that. So let's look at the output. So in 10.06, we did obviously add OSPF output in the debug module for OSPF, but it wasn't particularly easy to read because we didn't have any start indicators or stop indicators for the packet headers. In 10.07 we now have that. You can see here for the output and for OSPF v2 I now get a very nice start telling me the OSPF header started, and then it tells me that actually the packet is now finishing. So it's much easier and cleaner to read, and here I can see straight away I've got two process IDs affecting OSPF neighbors, process ID 2 and process ID 1. Process ID 2, I've got an authentication type 0 going on, and in process ID 1, I've got an authentication type 2 going on. Auth type 0, for instance, is no authentication between neighbors, and auth type 2 is using a cryptographic authentication with MD5 or one of the SHA cryptographic authentication methods that are now released in 10.07. So this output is much cleaner. And here's just a filtering that I did on process ID 2. So you can see it's much easier to read if you want to go to a more granular level and you know what you want to filter out on. You can get a much cleaner read of the output. Very helpful for customers. So a quick command summary affecting debug, very straightforward. Debug OSPF v2 or debug OSPF v3. Use the new packet submodule, and then underneath that we get our options: instance, IP, port, severity, and VRF, or carriage return if we want to capture all of those. And here I've just got clear debug OSPF v2 packet instance 2, which effectively means that I'm just capturing debug packets for instance 2 in the debug buffer for OSPF. Welcome to this video. My name is Steve Bartlett, and I'm here to tell you about the improvements we have in 10.07 for additional authentication encryption support using the SHA algorithm on OSPF v2 and in the Keychain. It's a software enhancement and it's applicable to all platforms, CX platforms supporting OSPF v2. So this is what we've got now to complement the MD5 authentication algorithm that we had prior to 10.7. We have the additional inclusion of cryptographic algorithm support for SHA-1, 256, 384, 512. The new commands under the interface here, we have IP OSPF SHA key, the key ID, the SHA, and this will be the password key, and we can apply a similar CLI string if we wanted to set up an encryption across a virtual link under a OSPF process ID, SHA key, key ID, SHA, and the key itself. We also have the same capability now in the keychain, so we could use the cryptographic algorithm supporting MD5 and the new cryptographic authentication methods for SHA through to 1512. On the left here, I've just put some authentication digest links, may be helpful for you and your customers when you are doing debugging. So here's some quick summary of the CLI examples. So under the interface, it would be interface number, IP OSPF authentication, and under authentication, and if it was under the router v-link, would have these additional commands to support along with the existing ones here, HMAC SHA through to 512. And if we were to translate this into a configuration between two switches that wanted to form an OSPF neighbor using this new authentication method, we would have this. Obviously our existing router processes will be up and running. Under the interface that we wish to have our neighbor adjacency formed, we'd have IP OSPF authentication, our authentication encryption algorithm that we use. I've specified HMAC SHA 512, and then another command, IP OSPF SHA key 1, SHA, and ciphertext is the actual password. In this example, it's a ciphertext format. But we do need, at either side of the link, we do need these three key ingredients to match. The first key ingredient we need to match is the authentication algorithm. That obviously needs to match at either side of the link. And importantly, the SHA key number, that needs to match either side of the link as well. And then obviously the third ingredient is the SHA actual password itself, presented here in the ciphertext, that needs to match as well as we've got here. And once we've got those three key ingredients, assuming that we've got our routing process configured correctly, we should form an adjacency between our OSPF neighbors on the desired interfaces. And we have the same enhancements in the keychain. So here's a quick CLI summary of what we can do in the keychain. So I'm creating a keychain called test1. I'm giving a key ID of key1. I'm now looking to use a cryptographic algorithm, and I've selected HMAC SHA. If I dropped this prefix here, we'd get the MD5 as an option as well as the HMAC SHA options. But I want to go for the HMAC SHA in this example, and then I've got my 4 options there for HMAC SHA 1 through to 512. So I'm selecting HMAC SHA 512. I then give a key string, I put it in plain text called Aruba, and then I just apply that underneath the interface. IP OSPF authentication keychain, IP OSPF keychain test1. So effectively I'm telling the interface to use keychain, the keychain ID of test1, and in test1 I've got my 3 key ingredients that I'm using, which is the key, the type of cryptographic algorithm I'm using, which is SHA-512, and the plain text password as well, which will now of course be encrypted. Some examples: we can mix and match with keychain configured on one end of the link on an interface, and the authentication directly configured under another interface on another switch. So here on the left hand side, switch 1, I've got the example of using an interface configuration of the authentication type using HMAC SHA 512. SHA key I'm using is 1, and the plain text is Aruba. And on the other side of this, the switch 2, under the appropriate interface that I want the neighbors to be formed, I've got a keychain configuration here, and I'm applying the keychain and keychain test 1. Yet again, we do have to make sure to bring our OSPF neighbors up, we have to have these 3 ingredients that matching either side, whether we're using directly under the interface configuration method or using the keychain. So HMAC SHA-512 is our cryptographic method algorithm that we're using. SHA-512, SHA key 1 that matches, and we've got a plain text of Aruba as well. So all things being equal, we've configured our OSPF correctly, we should form a neighborhood on our desired interfaces using the keychain at one end and directly underneath an interface at the other. If we do a show IP OSPF interface, either end of the link will get the authentication methodology that we're using, SHA-512 on this side, and then on switch 2, because we're using a keychain, it pops up with a keychain and giving our keychain ID that we're using. Okay, that was all I had for you in this short video. Hope you enjoyed it. Thank you.